We're live. Oh. Hello, my name is Hans Bernhardt.
I'm Simon Hamilton-Wilkes.
And we're here to teach you, well, how to describe NSX to a caveman. The notion being, well, before we start, that's our standard disclaimer. Everybody has read that. The notion being how to simplify what this thing called NSX networking virtualization is into a way that hopefully even a caveman could understand. So who are we? Simon Hamilton-Wilkes.
So I've been with VMware nearly 5 years in a couple of different roles. But I'm a networking background person. I'm a CCIE. More recently, I'm a VCDX. Whereas Hans,
I started at VMware in 2000, coming with a background of IT, not a networking expert, but I learned enough to be able to digest things into nuggets that non-networking people can understand. So we're coming from opposite ends of the spectrum for you. Now, our challenge here in the short time frame we have is simply to get the light bulb to go off, to help you understand just what is this core of NSX networking that makes it what it is. And then Simon will go into some of the more in-depth technology. But to do this, we have to go back in time and we have to start thinking about our basic virtualization again. And we have to come up with a methodology for how we approach what we're learning here and use that methodology and then apply it to NSX and networking virtualization. So we go back to VMware virtualization and we realize that we started with a physical device and we stuck this thing called a hypervisor on that device. And that hypervisor gave us a virtual machine. And that virtual machine had all the workings of the underlying physical machine, but that hypervisor was an abstraction layer. We understand that. And then we said when we combine our hypervisors together and we give them an underlying layer of physical storage that's shared and shared physical networking, and then we manage that with Virtual Center, we've aggregated our resources and distributed our resources so that our virtual machines can start floating around on this larger pool. But where's the brain? This is an analogy I like to use for teaching this, because you think, well, where's the brain of all this? Where's the brain of virtualization? Is the brain in a hypervisor? Is the brain in Virtual Center? Is it distributed? This is the first question you need to ask, and we'll get to that. So where's the brain of server virtualization? Well, is the brain in a hardware? Is the brain in a software? Is the brain in the operating system? No, the brain's in the hypervisor. No, the brain is distributed between the hypervisors and Virtual Center. So think about basic virtualization and the notion of Virtual Center manages all those hypervisors, but then you have things that are functions like high availability, where the ESX servers are aware of each other, they're aware of the Virtual Center server managing them, and if an ESX server crashes, one of the other ESX servers will take on those virtual machines and boot them back up again. That's a distributed brain when you think about it. High availability is just modules and hypervisors that are being managed by Virtual Center, but you have this management brain with this distributed brain of a function called high availability. So this is where I'm going to just read the slide. The caveman here says, I really need to think this one through. What is the function I'm trying to do? What and where is the brain of that function? These are the questions you need to ask yourself. Is it in a physical device? Is it in the OS, the software? Next question, how can I virtualize it? How can I put it in a hypervisor or in a virtual machine? How can I distribute it across multiple hypervisors and then manage it centrally? Okay, we understand server virtualization. We've already done this. One example, function, abstract physical processors and memory and map them to virtual machines. We understand that. That's been around for years. What's the brain of that function? Well, it's the ESX hypervisor on a physical server. Well, the function, manage it centrally. What's the brain of that function? Well, that's Virtual Center. Well, the function, high availability. What's the brain of that function? Distributed across ESX hosts and Virtual Center and so on. So think of that when you think about network virtualization. Go through those questions and ask yourself, how are we going to look at network virtualization? And here it is. Our presentation's over. Goodbye. Just joking. All right, so let's look at that. We need to understand this networking thing before, during, and after virtualization. So some of you may think that the initial VMware network virtualization was done in the hypervisor of the ESX server. We already gave you a virtual switch, but that's not true. There's many other layers of virtualization that we did not do in the initial go of the ESX server. But let's look at this for a moment and actually go to a physical switch. What's the function of a physical switch? Ethernet switching between my computers, blinky lights in the closet, okay? Well, what's in that switch in the closet?
And we could even go one level further back and say, what does a BNC cable thin-net network or thick-net network, even before that, when it was a yellow fire hose, Ethernet was designed as a broadcast medium where everybody could see everybody else's traffic, and you had the collision domain, and then you had the hub, and you moved to twisted pair cabling, and then switching comes along, and switching builds this table for the first time where it starts more intelligently figuring out where traffic actually needs to go and not sending everything everywhere except for broadcast and unknown traffic.
So what you're saying is in the old days, the brain was just like broadcast everything everywhere, and then...
Well, then the brain was in the NIC, because the NIC had this collision management, collision avoidance algorithm, and if you transmitted and hit somebody else's collision, collided with somebody else's thing, you backed off for a random time and then transmitted again. So the brain's in the NIC, but then the brain moves to a switch.
So an Ethernet switch. Those guys from Cisco's years ago that were sitting in a garage and they figured out, hey, why don't we have separate ports on a switch?
Well, it was Crescendo and Synaptics, but yeah.
Oh, sorry, I got that wrong.
Before Cisco.
Remember I told you I came from IT, he came from a networking background. But they figured out, like, rather than just broadcast everything all over the wire that everybody looks at, and then the brain of figuring out collisions would be in the individual network cards, why don't we build this thing called a switch? And the brain of that physical switch is a table of ports and MAC addresses, the individual MAC addresses of every network card that's attached to the ports in that switch. That's a physical switch. Those are the blinky lights on the rack or on the switch in a closet that your machine is hooked to with an Ethernet cable. Well, hey, let's take that brain that is usually in a physical switch at the top of my server rack and virtualize it. Let's put it in a hypervisor. Behold, layer 2 virtual switches in a hypervisor. This is an old slide, but it gets that point across that the initial go of network virtualization on ESX server was to simply put these virtual switches in the hypervisor, and the brains of those virtual switches was simply like, here's a table of ports, virtual ports, and MAC addresses of virtual machines NICs. Okay, so you can have multiple virtual switches on any one ESX hypervisor. But we want to distribute that across multiple hypervisors and manage and control it in a central place, aka virtual center. So later on, 2007, 2008 timeframe, behold the distributed virtual switch, where we said, let's distribute the brain of a virtual switch across multiple hypervisors and manage it with one virtual center so that that switch looks the same no matter where we vMotion our virtual machines.
And all we've moved at this point is the control plane. The forwarding plane is still in every individual hypervisor, but the problem with that, the original vSwitch, is consistency, because if your port group names aren't exactly the same and in the same case on every host, then you can't do vMotion anymore, or you can, but then the VM that you vMotion doesn't have any connectivity where it hits the destination host. So we did this to facilitate consistency, and then we gradually, now we've got this centralized control plane, we added more and more features on top of it so we could do more sophisticated things that physical top-of-rack switches and data center switches were also doing.
And interestingly enough, at this point with the vSphere having the distributed virtual switch, that was still not enough. And think about it, we've now created a layer 2 virtual switch that's distributed across all our hypervisors, but it stops at the boundary of the virtual data center in virtual center. So this switch can't be distributed across your entire data center or beyond to other data centers. So we need something else here, okay? So this becomes, hey, we've got distributed virtual switch, isn't that all of it? No, there's a lot of other networking stuff. What about distributing a virtual network across an entire data center or multiple data centers? Well, what about routing? What about firewalls? And there's more network functionality that we haven't virtualized yet. Behold. Okay, now the presentation's over. Goodbye. just joking. NSX, this is where NSX comes into play. How many of you are familiar with this model, the Networking 101, the OSI reference model?
Most people, that's good.
This is very good. Think about it. Now, this is an old model that we're familiar with that carves our network communication up into specific layers. You know, the physical layer being the actual wire that we attach to our machines. The Ethernet MAC layer being that switch layer we talked about, you know, ports and MAC addresses. The IP layer being, you know, actual internet protocol. We're familiar with IP addresses and pinging, and on up this stack.
And then one thing to remember here is the data link layer and the physical layer, they do hark back to that yellow hose cable, where everything sees everything. And a lot of the complicated networking protocols that have arisen in the past 25, 30 years have been in order to emulate that yellow cable by throwing lots and lots of complexity at the solution. So ATM lane in the 90s was one way of making a cell switching fabric look like a yellow hose. And then now we're doing NSX and other overlay networks, and we're having to do the same thing, where we have to deal with broadcast and unknown traffic. We have to somehow emulate that old yellow cable so that the Ethernet protocol and ARP and other broadcast-based protocols still function, because otherwise they wouldn't.
So then we got to reapply that methodology I said to you earlier about, you know, what's the function of each one of these layers? You know, what is the brain of the function that is at that layer? How do I implement the brain of that function either in a hypervisor or a virtual machine? And I've got to figure out how to distribute that brain across multiple hypervisors and manage and control it centrally. Now in this presentation, we're not going to go through every layer and do that methodology. I'm only going to take you to layer 2, but remember that. This is how you're going to learn this, and you're going to find that there's protocols associated with each layer, and you're going to say, what's the function of this layer? What's the brain of that function? How do I implement it in a hypervisor? What's the protocol of that function? Now, is it going to be in a hypervisor distributed, or is it going to be implemented just in a virtual machine? Okay? So now we get to what is NSX? Well, NSX is a network overlay. You may have heard of it being called the network hypervisor. And that begs the question, well, there's your network overlay in a pretty graph. And there's 2 virtual machines that are on the same layer, and there's another virtual machine on another layer called logical switches. But the reality is, it's like, well, what is a network overlay? You know, we say that, but then it's like, you need to describe it. What is a network overlay? So this is where we say, all right, well, let's go to layer 2. Let's look at that. And the function of layer 2, again, is that port MAC address table. But we need multiple switches here. We need multiple logical networks. We need to be able to create multiple logical networks into hypervisors and then distribute that across multiple hypervisors, okay? So the network overlay, in words, is we use network traffic encapsulation. We take any traffic in a network and we say, or in a hypervisor, and we say, we're going to tag you with an encapsulation protocol. And I'll give you an example of that here. I'm going to tag you red. And everybody else who has their traffic tagged with the color red, you're on the same network, okay? What's going to happen is, well, I could have a red tunnel, I could have a blue tunnel, I could have a green tunnel. All this traffic can be on the same network, but logically in the hypervisors, it's all separated, because this is red traffic, this is blue traffic, this is green traffic. So I'm using an encapsulation protocol to just tag everything that comes out of the virtual machines into the hypervisor. So the result is I'm going to have these multiple network tunnels on the same logical wire, or same physical wire, and then there's multiple logical network switches that can span data centers. They don't just have to be in a set of hypervisors. We can actually take that logic and spread it out across multiple data centers. And when we look at that, here's one example of an encapsulation protocol, VXLAN. In our physical world,
this is actually 2 examples, because VLANs are obviously another example of an encapsulation protocol, because you're just adding that tag at layer 2.
Good catch, because VLANs, we assume, are just part of our physical network now. VLAN technology has been around for years, and so we just think, hey, I've got a physical network, I'm tagging my physical network traffic with a VLAN ID, say VLAN 20, and therefore that's a logical network on my physical network. but we can, in the hypervisor, tag it further, tunnel it further, such that, again, if I have a network packet coming out of a virtual machine and I tag it with identifier 5000, it's now on VXLAN 5000. All virtual machines that are being tagged and untagged with VXLAN 5000 are on the same logical network. So with that in mind, with this tunneling notion by tagging the traffic, we can distribute our network across multiple hypervisors, and the mechanism of how we do that is that network overlay. In the hypervisor is a module called the tunneling endpoint, the virtual tunneling endpoint, and all it does is says, I'm here to tag the traffic and then send it to another ESX server, which will look at it and untag it if necessary. I'm here to tag the traffic and send it across to another data center where vSphere and NSX will be running there to untag the traffic and send it to a virtual machine over there. That gives me a logical network that spans across data centers. So when you look at the pretty picture, you see network overlay, and you go, oh, it's just tagging the traffic between all these ESX servers and then using the NSX manager as a management point for all of this. So if you look at the graphic, you see logical networks at layer 2. VXLAN 7000 is at first a blue box there. And the two virtual machines say ICU and ICU because they're on the same logical layer 2 network. The third virtual machine says, I don't see either one of you because it's on a completely different logical network. And
it can be more nested than that because we can have 4094 VLANs on every one of those VXLANs. So this VXLAN gives us this a point of multi-tenancy too, where you're separating all these different types of traffic, and then obviously, as we can go into, if we had lots of time, NSX can firewall every single port from every other port, so you can build this zero trust fabric where nothing can talk to anything else unless it's explicitly permitted by policy, which is obviously very powerful.
Well, and this is where the slide, this particular building slide goes into all those other layers, but in the interest of time, we can't go through them. But if you think that methodology again, well, let's say, for instance, that virtual machine that's on the upper layer can't talk to the virtual machines in the lower layer because they're two separate logical networks. Well, why don't we give them IP addresses and put a distributed logical router between them in those hypervisors? The brain of a router is mapping IP addresses to gateways to MAC addresses, correct? I get that right? Yeah.
It's maintaining a forwarding table of what needs to go where, and then when packets come in, looking at the destination, and then comparing it with the subnet and figuring out if that's local or if it's somewhere else, and if it's somewhere else, rewriting the packet and sending it somewhere else.
And now that's at layer 3. So you guys are familiar with IP addresses and pinging and gateways and that whole 9 yards. All we do is we say, what's the brain at that layer, the layer 3? Now you got IP addresses. Stick that in the hypervisors and distribute it across multiple hypervisors. Now all your networking is in the hypervisors. You've got layer 2. Now you got layer 3.
And because it's in the hypervisor, it's scale out. So every host can do wire speed forwarding of the traffic between the VMs on that host. And as you add more and more and more hosts to the cluster, and you get up to 64 nodes in a cluster or whatever, it just goes faster and faster because you're making it bigger.
Bingo. And so now our virtual machines can see each other on the internet, if you will. I'm sorry, not on the internet, but by way of IP address. But this other virtual machine says, I can only see you on port 80 and 443, your HTTP port and your security port. Well, why? Well, now you can stick the brain of a distributed firewall in the hypervisors. And like he was saying, you can literally take the traffic of a virtual machine as soon as it goes into the hypervisor, look at it and say, no, or only on these ports. So now you got distributed switch, distributed logical router, and distributed firewall all in the hypervisors. Take it a step further, and this is where I'm going to speed up because, again, you think of the layer, think of that model I showed you. What's the function of that layer? What's the brain of that function? How do you virtualize it in the hypervisor or in a virtual machine? If it's in the hypervisor, how do you distribute it? So in your learning after this, you want to go, well, what's load balancing? What's NAT networking and VPN, and how can we virtualize these things? How can we do these things programmatically so that we don't have to manually configure them all the time, so that we enable a very cloud-centric world where if we can have 4,000 VLANs and multiple millions of actual VXLANs, or whatever other tunneling protocol we're using to create all these tunnels, how can we programmatically do it so that I just push a button, my virtual machines are deployed, and I got all my networking right around it with security in an instant.
So you could have a VApp within VCD or VRA, and as you instantiate the components of that VApp, you can instantiate the load balancing, you can instantiate the security policy, you can instantiate the different logical networks, or you can put them all on the same logical network, because it doesn't make a difference at this point, because we're zero trust and we're only permitting traffic to flow where we've explicitly permitted it. Every VM on the same application can be on the same logical switch, and it doesn't matter that in terms of security policy, that's identical to having them all on different logical switches.
So at this point, I'm going to hand over to Simon. The most important thing I want you to get from me is that methodology. What's the function, what's the brain, how do you virtualize it, and so on and so forth. I won't repeat it again. And once you get that networking overlay, that first thing at the top of the slide, understanding what is that networking overlay, understand that everything else is just layers above that. That's virtualized, you're stuck in a virtual machine, and it all ties together.
Yeah, this layer model of OSI or lasagna or however you want to look at it is sort of a key thing. When back in the 90s when I was doing Cisco for the first time and I did CCIE and whatnot, the OSI was such a fundamental part of all those studies because so much is based on the lowest level. So I mean, if your PC can't connect to the network, do you start by figuring out if your device driver's unloaded from memory, or do you look and see if the Cat5 cables come out of the wall? You start at the bottom, at the lowest layer, the physical layer, and gradually work up until you find out that Google pushed an update to Chrome, which has invalidated the SSL certificate of the website you're trying to get to, and but starting at the bottom is the logical way to go usually, unless you have extra information. And then this is the sort of current NSX marketing slide, relatively current vision for NSX everywhere. And when we've been referring to NSX, we could have been specific and said NSX data center, because now there's NSX cloud and there's NSX, the Velo cloud, NSX WAN.
And it gets bigger and bigger.
Yeah, so we make it a more complicated message every year. But then within NSX data center, we've got the extra complication now that there's NSX-T in addition to NSX-V. So NSX-V is this thing that is most of the NSX that's out there and deployed in the 7,500 deployments that Pat was talking about on Monday. T is the sort of new shiny NSX for addressing new use cases. So the sort of big one is cloud native apps and containers, because it's been built with that specifically in mind. And I'm not going to go into all the details because it's massively complicated. But the idea is you can do microsegmentation for containers running on VMs and have the same sort of troubleshooting and monitoring and tool set for containers, and being able to apply security policy and rigor to those container services that you can previously apply to VMs. Because 4 or 5 years ago, when containers were the new shiny thing and everybody was like, oh, containers are going to eat VMware's lunch because everybody's going to go to containers and cloud native apps and have no reason to do VMs anymore. It didn't take very long, and we had some good marketing and some good products around it, but we've managed to convince people, I think, that at least in the enterprise, still being able to have a lifecycle management tools and have the sort of enterprise management tools that we've spent the last 20 years evolving is tremendously valuable and worth the cost of having VMware involved in the thing.
Well, what I like about the container thing is, if you think about this, okay, so you've got virtual machine sitting on your NSX network overlay, and then you have microsegmentation based on that distributed firewall, and you can stick a container in a virtual machine, and one container in a virtual machine, and lock that communication by the NSX firewall, and think of that as having control of that container. Now, as soon as you stick 2 containers in that virtual machine, that model doesn't work anymore.
Right.
So enter NSX-T, which can get you around that and actually look at individual containers running in one virtual machine and have that control.
So this doesn't look that different from NSX-V in that we've got a separate one management plane, and then we've got a control plane, which is the controllers. And the main function of the controllers is emulating that yellow cable, because they're the means where there's a mapping kept of what containers or VMs live on what hosts, and how to map those broadcast on unknown packets to where they need to go, because otherwise communication wouldn't work. And then the important bit here in the data plane is T supports KVM in addition to ESXi, so we're no longer locked to vSphere. So the management plane also, where in V, there's a one-to-one relationship between NSX Manager and vCenter. vCenter is no longer assumed to exist. So NSX-T is this more self-contained thing, which doesn't need a vCenter to be present in the environment at all. Because if you're running on KVM, why would you have vCenter?
So it's multi-hypervisor.
And then the other sort of key difference, I mean, there's been many hours of sessions on T this week, and I'm not going to try and
we can go to the party
into any
tonight.
of those that detail.
We can talk to them at the party tonight, and we'll describe it.
But one thing is the logical routing in T is in a 2-tier model, where tier 0 is usually the tier that's owned by the service provider or the IT infrastructure provider, and then tier 1 is a layer further away from the physical, and that's the layer where you might give it, it might be more dynamic, and there might be tier 1 routers instantiated for a new vApp, for example. And then the routing between tier 0 and tier 1 is auto-magic in T, which is great. You don't have to muck around creating a transit network and sticking an IP address and running a dynamic protocol or any of that. T just does all that automagically, which is great.
I apologize, but I did not correct you on routing. It's routing.
Depends where you're from.
I've gotten so used to him saying routing now that I...
Yeah. I'm trying to think if there's any other nuggets I can say about T in the minute we have left.
Do a quick wrap up.
Yeah.
And,
go ahead.
So in a nutshell, we've compressed this whole, think of all the presentations, all the education you can have on NSX, and we've gone into a very small nugget for you. And so the message is here, building for you from basic virtualization up and layering these things on top of each other is to get you that methodology. You got to look at the layer. You got to think about what is that layer doing, what's the function, what's the brain, how do you stick it in a hypervisor, how do you distribute it, or how do you stick it in a virtual machine and make it work for you that way. You do that with just basic virtualization, which which you can comprehend because that's been around for a long time. And you start to think of the hypervisor as just this place to stick more brains, to stick more functions. Then you start thinking of that the same way with networking, and then work your way up the stack. A switch on a hypervisor, a distributed switch on multiple hypervisors managed by Virtual Center. Wait, there's more layers of network functionality that need to be virtualized. Look at that OSI model and say, what's the layer, what's the function, what's the protocol, what's the brain, how can we stick that in a hypervisor, how can we distribute it, how can we stick it in a virtual machine, and so on and so forth. Work your way up each one of those stacks, and then look at what NSX is doing for you. That one slide where the I can talk to you thing helps describe that. Then take it a step further, and when you go from NSX-V, which is vSphere centric, to NSX-T, which is multi-hypervisor centric and kind of its own independent networking world or cloud, if you will.
Self-contained.
Self-contained. Then you can understand how much bigger it's getting and how these things work. And you don't have to be, you can be an IT person like me. You don't have to be a rocket scientist like Simon. Well, I'm not necessarily a rocket scientist, but somebody who makes very good coffee, and I just go to, 7-Eleven. That was not an endorsement, just It was just a joke to kind of finish things off.
Yeah, so you get how we sort of going from the lowest level, and then you can enhance more and more functionality. And then, we as a company, as we acquire or develop other products in-house, we add to that functionality. So now we've got app defense coming in with this next generation microsegmentation, where on the one hand we're looking at the processes and what's happening inside the VMs, and then we're taking that back and into the NSX policy so that we can add to the security posture of the environment. It's pretty cool stuff.
So basically that's it in a nutshell. Feel free to ask us questions afterwards, and thank you.